Hey guys, my name is Reno and today we're going to be learning about angles. Alright, so first off, types of angles. So here we have a right angle or 90 degrees. In this diagram there is not a square right here, but in most cases you're going to see a small square right here indicating that this is a 90-degree angle or a right angle. So this is called an acute angle. So there are many acute angles. Unlike this where there's just one measure, there are multiple measures for this. There are multiple possibilities, but this angle or any angle that can be described as an acute angle should be less than 90 degrees. Next, let's take a look at the straight angle. This is going to be exactly 180 degrees. We can identify a straight angle with two things. There's going to be a semicircle indicating that this is 180 degrees, and there's going to be a straight line telling us this is going to be a straight angle. And lastly, this is an obtuse angle. It's going to be greater than 90 degrees but less than 180 degrees. Okay, so next, naming angles. So there are three ways to name an angle. You can use points on each of the rays and one vertex, and you can use a number given on the diagram, or you can use the vertex of the angle to name it. So here in our diagram we can use a point on each ray and one vertex. So the point A is on the first ray, point C on the second ray. We can say angle ABC or angle CBA. One thing though, whenever you're gonna use this for naming, the angle B will always be in between A and C. Next, using a number given on the diagram. So here we're given 1, so this should just be angle number 1. Next, using the vertex to name it. The vertex is angle or point B right here, so we just say angle B. Alright, next, complementary angles. So complementary angles are any two positive angles that sum up to 90 degrees. So here in our first angle, we see in our first example, we see two angles, angle AOD and angle DOB. The measure of angle AOD is 30 degrees and the measure of angle DOB is 60 degrees. So when we sum both of them up, we get 90 degrees, telling us that these two are complementary angles. So and then next, we have the first angle of 27 degrees, second angle of 63 degrees. When we sum both of them up, we get 90 degrees. Then finally, we have our first angle of 25 degrees, second angle of 65 degrees. We sum both of them up, we get 90 degrees. Another way that these to prove that these must be complementary angles is a small square right here telling us that this is a 90-degree angle, so these two must sum up to 90. Alright, next, supplementary angles. So supplementary angles are angles that sum up to 180 degrees. So for example, in our first diagram here, we have 60 degrees and 120 degrees. When we sum both of them up, we get 180. And then next, we have angle A and angle B. When we add both of them up, we should get 180 degrees. That is because this is a straight angle, and two things prove that. There's a straight segment right here, and the semicircle indicating that this is a 180-degree angle. And then finally, our first angle here is 100 degrees, and our second one 80 degrees. When we sum both of them up, we get 180 degrees. Alright, some practice with that. So what you're gonna do is name if these angles in the two diagrams given here are complementary or supplementary, then solve for the unknown angle. Pause the video, give it a shot, come back, and I'll give you the answer. Alright, now that you're back, first off, for the first diagram, this is going to be complementary. If you put these two angles right next to each other, they're going to form a 90-degree angle, which tells us that these are complementary angles. Alright, so first off, 34 plus x should equal 90. So according to our complementary angle definition, if we add these two angles, we should get 90 degrees. Let's bring 34 to the other side. We get x equals 90 minus 34, and then x equals 56 degrees. And then in our next diagram, we have x and then 118 degrees. This is going to be supplementary angles because we are given a straight line here telling us that this is a straight angle or 180 degrees total. So we're just going to want to do x plus 118 equals 180 degrees. Subtract 118 from both sides, which gives us x equals 62 degrees. Alright, next. Angle addition postulate. So, if t is in between angle RSV, then angle RST plus angle TSV should equal angle RSV. So this diagram proves the angle addition postulate. So here we have our original angle, angle RSV, and then point T in between angle RSV. So that tells us that angle RST and angle TSV must equal angle RSV. Alright, here's a practice. So according to the diagram, you need to solve for x and then find the angles given in the diagram. So once you solve for x, plug in the values and then solve for the angle measures. Pause the video, give it a shot, come back, and I'll give you the answer. Alright, now that you're back, first, angle ABC, the straight angle, or 180 degrees, is equal to angle ABD, which is 5x plus 10, and angle DBC, which is 2x minus 5, should equal 180 degrees. So next, 180 degrees is equal to 5x plus 10 plus 2x minus 5. We're just plugging in values, and then we're going to sum up our variables and then our constants, which gives us 180 degrees is equal to 7x plus 5. We're going to subtract 5 from both sides, which gives us 175 degrees is equal to 7x. Divide 7 from both sides, which gives us x equal to 25. Alright, now that we know the value of x, let's solve for each of the angles. So first off, angle ABD. The angle measure for that is 5x plus 10. So let's plug in our value for x, 5 times 25 plus 10, 125 plus 10, and then our angle measure should be 135 degrees. Next, for angle DBC. Angle DBC, the angle measure was 2x minus 5. Plug in our value for x, 2 times 25 minus 5, 50 minus 5, which gives us 45 degrees. We know that these answers are correct because when we sum both these angles up, we get 180 degrees. Alright, next, linear pairs. So, linear pairs. Two adjacent angles that are a linear pair when their non-common sides are opposite rays. So, for example, in this diagram, as you can see, this ray, ray B, is their common side for angle AOB and angle COB. The B is the common side, and then the non-common side is ray C and ray A. Since they're both in opposite directions, we know that this is a linear pair. So you're going to be able to identify linear pairs because of the fact that it's going to be a straight angle. They're both going to sum up to 180 degrees, and they're going to look like a straight angle. So you should easily be able to identify linear pairs. Next, vertical angles. So, two angles are vertical angles when their sides form two pairs of opposite rays. So here we have this angle right here and this angle right here. So in order for these to be vertical angles, their sides need to form two pairs of opposite rays. So for these two angles, this side and this side are opposite rays, and this side and this side are opposite rays. So this proves that these two are vertical angles. So you'll be able to tell these because these angles will be pointing in opposite directions, and they'll be like really close to each other, meeting like a common point like this. Alright, identifying angle pairs. So what you need to do is name which angles are linear pairs and which angles are vertical angles. Pause the video, give this a shot, come back for the answer. Alright, so I asked you guys to name all the pairs of linear pairs, all the angles that are linear pairs, and all the angles that are vertical angles. So let's start off with the linear pairs first. So first off, we have angle M and R. So angle M and R, they're a linear pair because this ray and this ray are opposite. That applies to angle S and A as well. And then for angle C and O, they're linear pairs because this angle and this angle are opposite. That's the same thing for angle T and E. But there are more. So more linear pairs are angle T and angle C. This ray and then this ray are opposite. That's the same thing for angle E and O. So angle M and S are linear pair because this ray and this ray are opposite, and angle A and R are linear pairs because this ray and this ray are opposite as well. Now to name the angles that are linear or vertical angles. So now angle M and angle A. This is a vertical angle because this ray and this ray are opposite, and this ray and this ray are opposite, and those are the rays that make up the angles, so they're vertical pairs. S and R are vertical pairs, C and E are vertical pairs, and T and O are vertical pairs. For all of them, as we can see, the rays that form them, or the sides, are all opposite to the other angle that is their second vertical pair. So I hope this video was educational, and I hope you guys enjoyed this, and come back for more educational videos like this.